Good morning students, this is Junita Mukherjee from SS Public School. So today we are going to do the continuation of this particular chapter, units and measurements. And I told you that estimation of a very small distance we will today study, and the size of a molecule. Okay, we will study like today this particular topic. So let's start this one. To measure a very small size like that of a molecule of 10 to the power minus 8 to 10 to the power minus 10 meter, we have to adopt a special method. We cannot use a screw gauge or similar instrument. Even a microscope has a certain limitation. An option microscope use visible light to look at the system under investigation. As light has given light features, the resolution to which an optical microscope can be used in the wavelength of light. A detailed explanation can be found in the class 12 physics book. For visible light in the range of wavelength from 4000 to 7000 Armstrong, that is a visible range of that of the light from the category Vibgyor, and 1 Armstrong is equals to 10 to the power minus 10 meter, and hence an optical microscope cannot resolve particles like sizes smaller than this. So instead of visible light, we use an electronic beam. Electronic beam can focus on properly designed electric and magnetic field. The resolution of such an electronic microscope is limited finally by the fact the electron can also behave as a wave. So you will learn more about in this chapter 12 in class 12, and the wavelength of an electron can be as small as the fraction of an Armstrong. So such electron microscope with a resolution of 0.6 Armstrong has been built. They can almost resolve atoms and molecules in a material. In recent time, the tunneling microscopy has been developed, in which again the limits of the resolution is better than an Armstrong. It is possible to estimate the size of the molecule. A simple method for estimation the molecular size of oic acid is given below. The oic acid is a soapy liquid with large molecule size of the order of 10 to the power minus 9 meter. The idea is to first form the monomolecular layer of the oic acid on water surface. We dissolve 1 centimeter of oic acid in alcohol to make a solution of 20 centimeter cube. So then we can take 1 centimeter cube of the solution and dilute it in 20 centimeter cube using alcohol. So the concentration of the solution is equal to 1 upon 2 in 20 into 20 centimeter cube of the oic acid per centimeter cube of the solution. Next, we lightly sprinkle some lycopodium powder on the surface of the water in a large straw, and we put 1 drop of this solution in the water. The oic acid drop spreads into a thin, large and roughly circulated film of molecular thickness on water's surface. Thus, we quickly measure the distance of this diameter of the thin film to get this area A, and suppose we have dropped n drops in the water. Similarly, we determine the approximate value of each drop is equal to each drop, that is V centimeter cube. So volume of n drops of solution will be given by n into V centimeter cube. Amount of the oic acid in the solution will be given by n into V into 1 upon 20 into 20, that is 40 centimeter cube, and T will be equal to volume of the film upon volume area of the film, that is T equal to NV upon 20 into 20 into A centimeter. Okay, so if we assume the film has a monomolecular thickness, then this becomes the size or the diameter of a molecule of an oic acid. So value of this thickness comes to be at the order of 10 to the power minus 9 meter. So this is how the estimation size is being method. In this method, we are using this microscopically. We are using this thing, and with the help of microscope with a resolution of 0.6 Armstrong, we just done this particular thing. And simple method for estimating the molecular thing is given below, and thus we have done with the help of oic acid on the water surface and dissolve the alcohol oic acid in the alcohol of 20 centimeter cube. And thus we refer this reference has been taken out. So range of length now. Range of length. Range of length means it can be light year. Length can be defined on the basis of meter, centimeter. Okay, then meter, centimeter, Fermi, Armstrong, astronomical unit, light year, parsec. Okay, so this is just because of the size of the object we come across the universe is of very wide range, and this wide range, because of this wide range, we are using the size of the order 10 to the power minus 14 meter. Okay, so we are using this size of tiny molecules of the size of the order of 10 to the power 26 of the extent of the observable universe. So we are able to do this range up to parsec. That is, 1 parsec is equals to 3.08 into 10 to the power 16 meter. 1 light year is equals to 9.46 into 10 to the power 15 meter. 1 Armstrong unit is equals to 1.496 into 10 to the power 11 meter. 1 Armstrong is equal to 10 to the power minus 10 meter, and 1 Fermi is 10 to the power 15 meter. Measurement of mass. Measurement of mass is the basic property of matter itself, and we are using different National Physical Laboratory in India, in New Delhi, which is dealing with the atoms and the molecules, which is convenient for in the convenient units, that is Unified Atomic Mass Unit, which is already expressed as the mass of atom. 1 atomic unit is equals to 1 upon 12 mass of an atom of a carbon, and isotope is 16 to 6, including the mass of the electron, that is 1.66 into 10 to the power minus 24 kg. So this is how the mass is being measured, and in this chapter we will learn about the Newton's law of gravitation using the gravitational method, and we are able to learn the larger masses of the universe like planets and stars based on Newton's law. Range of mass. Range of mass means it should be the size of the proton or the size of the electron, so the size of the hydrogen atom, then wavelength of light, thickness of a paper, radius of an earth, then size of our galaxy. Depending on these values, we are able to find out the range and the order of the things, that is basic range. And in this basic range we are able to find out the length of these items, that is size of these atoms, that is length, or you can say is the mass of these items. Okay, so masses will be given by size of the proton, which is given by the length in the table, in this particular table 2.3. the range and the order of the length is being given to you. So the masses of the object we come across the universe is very wide, and these may vary from tiny masses of the order 10 to the power minus 30 kg of an electron to the huge mass of about 10 to the power 55 kg, which is known as the known universe. So given range and order of the typical masses of the various objects is given in table 2.4. There is a table in 2.4 itself in which the masses of the masses is already given, that is electron, proton, uranium atom, red blood cells, raindrop, then automobiles, moon, earth, sun, Milky Way, galaxy, and so many things. So I hope that this particular topic is being very much interesting to you to note down, because it is nothing but just to know about what are the things which are given in the units and measurements, to know about this particular category of masses, then length and range of mass. So in the next topic we will talk about the measurement of time and the accuracy, precision, and the instrument and error in the measurements we will talk about, and how to correct this error we will discuss in broadly. So thank you for this particular topic to explain to you, and please, if you have any doubt, please comment in the comment section. Thank you, students.